All right, guys, I'm going to go over Rolles Theorem in this video, and I'm going to apologize right now because my voice is pretty raspy because I'm still a little sick, but I'm going to try my best, okay? Okay. All right, let's go. So, Rolles Theorem first has to meet three conditions. So let's say that we got a function f. If f is continuous on an open interval, on a closed interval AB, it has to be continuous on the closed interval AB. It also has to be differentiable on the open interval. Differentiable on open interval AB. Third condition is that the endpoints are going to be equal to each other, so that the y values at A and B are equal. So f of A and f of B equal each other. So the third condition, f of A equals f of B. If these three conditions are met, then we can say that there's at least one horizontal line, that's one horizontal tangent line on the interval from A to B, at least one somewhere. So let me write that first formally. Then there exists at least a C value in AB such that f prime of C is equal to 0. Interesting. So what does that look like? Well, let's break it down. I'm gonna draw it up here. I don't want to get down. Well, maybe I will have to. Maybe they just come over here so you can see it as I'm writing it. Actually, no, I'm gonna write it up here. My back kind of hurts. So let's try some basic sketches. So AB most simple case would just be a horizontal function. So again, let's say that the y values at A and B are going to be 4. They have to be equal to each other. So they're both 4. And this is just a horizontal line. So this function is essentially the function f of x equals 4. Now, does Rolles theorem work? Yeah, because you're just looking for a horizontal tangent line anywhere between A and B. So if you just pick a point here and draw a tangent line, there you go. And let's call that value C, f of C. So then here, f prime of C equals 0. Horizontal tangent line. And you can find an infinite amount of horizontal tangent lines. You can call that D, you can call another one E, and so forth. You can find an infinite number of horizontal tangent lines on a horizontal function. Another case, we could have maybe something simple where it just does like a parabola thing. Maybe it just does something like this. And again, let's just say these values are 5. A5, B5. And then what is this saying? Again, that there's some horizontal tangent line that you can draw between this point, and this point. And it would probably be right over here. This is f. This is c f of c. At this point, f prime of c is tangent. I mean, it's horizontal. I need to wake up. In the third case, you could say, or a third general case you want to think of, is what if it does this sort of thing twice? Maybe it goes like this, and it goes like that. But again, at the endpoints, let's say the endpoints are 3. So there are actually, you can see there's probably 2 horizontal tangent lines. One over here, we'll call that C, and one up here, we'll call this other one like D. So 2 horizontal tangent lines in that case. Rolles theorem says there has to just be at least one, and keep in mind the other conditions. It has to be continuous, which you can see that they are, and differentiable. Think of differentiable as a smooth function. Smooth. Meaning it's not going to be making any spikes or sharp points or triangles or anything that's going to like stab you. It's going to be like nice and flowy, you know? So that's the kind of the intuition. That's just the basic geometry conceptual understanding, if that makes sense. But let's go through an actual example. Okay. So I'm going to erase this. Yeah, I'm going to erase this. Because it's a video and you can just look back if you need to see what I'm talking about, but I want to have enough room to go through the work of the example. Let me hydrate here. Okay, so let's look at this example. X cubed plus 3x squared is x minus 4. Minus x cubed plus 3x squared minus x minus 4. And the interval is going to be from -3 to 1. So like we're going to show that Rolles theorem applies here, or let's show that if these conditions are met, it's going to apply. Now, just a side note. I would really recommend you guys to practice writing these out by hand, not just to memorize them, because when you do your AP exam, they're not going to be able to just hear you or know who you are. They're going to need to see you write this out clearly. So that's why I wrote it out like it's 3 different separate lines, so they can see that you know that 3 conditions have to be met. All 3 conditions have to be met. So let's check each one first, one at a time. So let's check to see if it's continuous on this closed interval. And the way we go about that is that we simply state that since this is a polynomial, it's going to be continuous on since f since f is a polynomial, it is continuous on, and make sure you make it a closed interval. And I like to put like a check mark to show you got one down. And then also just add, and it's differentiable because it's a polynomial. If it's a polynomial, we can say that it's continuous and differentiable. Differentiable on the open interval. Differentiable on AB. So I recommend that kind of shorthand because it shows 2 clear, two clear conditions that are being checked. Now, third condition, let's check to see that the y values at the endpoints are equal to each other. So we're going to see f of -3, f of -3, and what f of 1 are equal to. F of -3, plugging this in, -27, plus 27, minus plus 3, minus 4, so what is that, 3, -1. And this should give us -1, so 1 plus 3 times, plus 3, yeah, minus 1, minus 4, 4, yeah, good, -1. These are equal. So the three conditions are met. But that's just what we need to do before we can say that there's going to be a c value or another value of x between -3 and 1 where there is a horizontal tangent line. So let's find the derivative and then set the derivative equal to 0 and solve for those zeros. So I'm going to separate this so it doesn't interfere. Is this marker dying? Yeah. So let's find the derivative. So f prime of x is going to be 3x squared plus 6x minus 1 using the power rule. Let's set this equal to 0. 0 is equal to 3x squared plus 6x minus 1. Now, this is not a simple whole nice answer, so you can use your calculator and we're going to use a calculator because this is going to be like some decimal answer. But let's break it down by the quadratic formula. So using the quadratic formula, we're going to have that x will be equal to -b plus or minus the square root of b squared. So 6 squared minus 4a times c all over 2a. Hey guys. $36 minus plus 12, so 48 over 6. So we're going to have two answers. Where should I write this? I'm going to write this over here. Over here. Then I want to go to that side. So we're going to have one value. We're going to have x1, one of the values where we're going to add this discriminant and then divide, and another one where we subtract. So using calculator technology, -6 plus, we'll get about 0.1547 for the first one. And for the other one, -6 minus the square root of 48 divided by 6, -2.1547. Now, even though I put x, these are just going to be your c values. So this could be c1, we can call this c2. Now, the last thing, in case they're really strict on your grading, which a lot of them are, show them that you know that these values have to be between -3 and 1. So let me just say it. So we know that 0.15 is less than 1 and greater than this, and -2.15 is also between there. So we can say that since C1 and C2 lie in this open interval, then we have shown that Rolles theorem holds here. So lie in -3, 1. Rolles theorem holds true here. Sorry about my throat, but there you go. I hope that helps. I hope that breaks this down. This is going to lead you into the real application that you're going to probably have, or you're definitely going to have problems on the mean value theorem, and you may have a free response problem on it. So I'm going to show you that in the next video. But again, let me know if this helps you out, or if you have any questions, or feedback is always helpful. I'm not going to say I'm perfect, but I appreciate you guys watching. So please subscribe and tell your friends, tell your peoples, and I'll see you guys in the next video. All right, bye. See you guys.